Hi class, this is Mr. Pyrus. This year I'm doing something a little bit different in that I'm going to be recording a video of our PowerPoints that we'll be doing in class. And obviously by you being able to access this, you can see that it's in the Dropbox and you can take a look at it. So this is going to be lesson 1 of hopefully a whole series of them, and I hope that you can use them for review. If you have any questions about the concepts of the lesson, that'll be a great opportunity. What we're not going to be doing with this is we will not be doing the power-ups, and we're not going to be doing the written lessons in these videos that I'm going to be doing, but instead the written assignments and the homework assignments and their solutions will be in a different area in the Dropbox. So I expect that you'll have access to them over there. But we're just going to go through the important new concepts in the lesson. Now, lesson 1 obviously is a review lesson, and you should be fairly familiar with most of this stuff. If you're having difficulties already, come and talk to me in class tomorrow and we'll be able to figure this out. But we're dealing with number lines, we're talking about different sets of numbers, and we're talking about comparing different integers. So, before we do that though, we're going to get into the problem solving process. And the problem solving process is pretty simple. We're just going to go into a 4-step process here. It will become more elaborate as you get into a profession, as you get into a job. When you grow up and get older, you'll be able to articulate it a little bit more definitively, more steps. But they're all based on just a simple 4-step process here. And the first step is understand the problem. Basically, it's saying know where you are, know where you're going, know what you know what you need to know, and figure out how you can get from point A to point B. And so first you got to say, here I am at point A, there I am at point B, and what are the different avenues I have to get there from point A to point B. After you do that, then you come up with a plan. You look at the different options to get from point A to point B, or from where you are to where you need to be, and you go and plan that out. And you say, I want to do this in 1 step or 2 steps or 3 steps. Now, keep in mind that most of this is talking about with word problems, but even if you have a simple equation, you will have to work this through and work out a plan. So you do that. You come up, you make a plan, and then finally in solving the problem, all you do is follow your plan. And then once you follow the plan, that's the steps that you take to solve the problem. And of course, after you've solved the problem, you have to test it. You have to check your answer. You have to look back. You have to see if you've actually gotten the right answer. Now, you know how to do that. You compare, if you've done an addition problem, you go and subtract. Or if you've done a multiplication problem, you divide. But what you do is you need to make sure that you're answering the right problem. If they're asking you how many boys are in the room, don't tell me how many girls are in the room, because I don't care. I want you to give me the right answer to the right question. Now finally, we have something that I call the red face test, and we've talked a little bit about it in class. And the red face test is very simply, can you go and give that answer without a red face? Can you give that answer without people snickering? Can you give that answer without being embarrassed or ashamed or sad that you actually came up with it? Is it a realistic, reasonable answer? That's what we're asking for. Because don't give me some outlandish number. Don't give me some outlandish solution. Instead, go and give me a reasonable answer. And that's how we call the problem-solving process. So now let's look at Lesson 1. Lesson 1, first we start off with a number line. You've seen these before. Starts at 0, goes to the right, 1, 2, 3, 4, 5, all the way up to positive infinity. And then it goes to the left, -1, -2, -3, all the way to negative infinity. And that's what we call our number line. Now, we're going to use the number line to go and talk about different sets of numbers. And the first set that we're going to talk about is the counting numbers. Now, you remember counting numbers. Ever since you played hide and go seek the first time, you counted. And you counted 1, 2, 3, 4, 5. So that's what the counting numbers are. You don't start counting at 0. You don't start counting at -2. You start counting at 1, 2, 3, 4, 5, and you get up to 50, and you say, ready or not, here I come. And that's the counting numbers. The next set is the whole numbers, and counting numbers are a part of, or what we call a subset of the set of whole numbers. Whole numbers include all the counting numbers and the number 0. And so that's all the numbers from 0 to the positive. So what are we going to do with all these negative numbers over here? You guys all know that. They're the integers, right? And the integers are all the complete whole numbers. I mean, whole numbers is a set of 0 through infinity, but these are numbers that are distinct numbers. There's no fractions or anything like that. And that's how we go. So the counting numbers is a subset of the whole numbers. Whole numbers is a subset of the integers. So then we look at what is absolute value. Absolute value is pretty easy in that it's always a positive number. Why is it a positive number? Because the absolute value is the distance that a number is from 0. So if I ask, what's the absolute value of 3? It's 1, 2, 3. 3, it's 3 to 0. What if I say, what's the absolute value of 5? It's 1, 2, 3, 4, 5. Actually, it'd be 1, 2, 3, 4, 5. But that's its distance from 0. What about -4? From 0, it's -1, -2. It's 1, 2, 3, 4. So it's always a distance, and the distance is always a positive number. You cannot have a negative distance. So absolute value, whether it's a negative number or a positive number, it will be that positive value for that number. Okay, so let's look at a couple of examples. The first one is arrange these integers in order from the least to the greatest. -3, 3, 0, 1. Well, obviously, the least is the negative number, since there's no other negative numbers, and then there's 0. And you know that 1 comes before 3's, right? So that's how we go. -3, 0, 1, 3. The next example is to compare -3 to -1. And -3 is to the left of -1, so it's less than -1. So then we compare the absolute value of -3 to -1. And the absolute value of -3 is what? It's 3. The absolute value of -1 is 1. Is 3 less than -1? Is 3 less than 1? No. 3 is greater than 1. Looking at example 3, it says graph the numbers in the sequence on a number line. -3, -1, 1, 3. That's just taking the number line and picking out those points. You see, -3, -1, 1, and 3. Example 4. Graph two numbers that are 4 units from 0. Well, 4 is 4 units from 0. And what's the other number that's 4 units from 0? It's the other number that has the absolute value of 4, which is -4. And so you graph them both on the number line. And finally, now we get to the practice set. Number 1, number A, letter A, says arrange these numbers in order from the least to the greatest. Okay, so -4 and -1 are negative, so it's got to be one of them. -4 is farther to the left, so -4 is the least, -1 is next, 0 is next, then 2, then 3, right? Just how it's set up on a number line. Then, which number in problem A is an even number but not a whole number? Well, whole numbers in problem A are 0, 2, and 3. So, it's got to be -1 or -4. Is -1 an even number? No. So the answer is -4. So then if we compare -2 to -4, which one is further to the, which way does it go? -4 is further left on the number line, so -4 is less than -2, or -2 is greater than -4. In D, it says graph the numbers in this sequence on a number line. 4, -4, -2, 0, 2, and 4. Just go and set your number line and pick out the points. For E, the absolute value of -3, it's the distance from -3 from 0 is 3. But you know what? That's equal to the absolute value of 3, which is also 3. In G, it says write two numbers that are 10 units from 0. Well, 10 is obviously 10 units from 0, and it's -10 as the absolute value of 10 also. And finally, it says write an example of a whole number that is not a counting number. Well, we talked about that already. Counting numbers are 1, 2, 3, 4, 5 through infinity. Whole numbers include 0 and 1, 2, 3, 4, 5. So your obvious answer here is 0. So that's lesson 1. This is still review. You should be getting this. If you're not getting this, feel free to go and call me aside tomorrow or sometime this week and say, I'm not sure I understood that, Mr. Pyrus, but hopefully this is still review and you're getting a handle on this. I hope you have a blessed evening.